entertain us with data-driven manufacturing. We know nothing about it.
Okay. Thank you, Calvin. Before we get started, everybody can see the screen, I assume?
Yep.
Okay. Just make sure David's on the call. He's on a actual phone line. Just want to make sure, Dave, you're on. Okay.
Yeah, I'm here.
Okay, good.
Awesome.
Okay. Well, thanks everyone for your time. And what we're going to do here briefly is we want to talk a little bit about, for those of you who have seen the presentation before, a lot of what we talk about with Tempus, our OEE machine monitoring software, is how the product actually works. But what we really want to focus on today is the why. What is the business case for deploying a project like this in your shop? What does the return on investment look like? And we're gonna show an example of that later in our presentation. But for everyone else's benefit, I want to go through some slides here to get everyone a little acclimated to what we do in terms of machine monitoring. One of the things I want to mention real quick is, and the reason we're on this call with Coda Bears is Calvin and Fred and the team have actually developed a product you may be familiar with called the Coda Bridge, which actually connects the Epicor, I want to say 9.02 and beyond, Calvin, I think is right, into our Tempus software. So it's a native connection, and we have a couple deployments of that already, and I think that's part of our reason for being on here, to understand and how you can ultimately connect an MES MOM system that we have into Epicor and push work orders and product standards down into our system for full OEE measurement. Okay, so there we go. This is a brief introduction that we're going to do. I'll talk about Dave and myself here in a second. We're going to talk about data-driven manufacturing, the 5 steps that we use to implement a project like this, and ultimately how this ties into continuous improvement. We'll talk a little bit about that, why OEE is the metric going forward, and our MPMM, our Merlin Performance Management Model, and what that means to you in stretching and squeezing all the juice out of the particular deployment that we have. And then lastly, looking at how we connect to Epicor, as we talked about with the Coda Bridge. I'm the Midwest sales manager for Memex. I'm based here in Chicago, and David McPhail, who's also on the line, is our president and CEO. Any questions you have or points you want to make during the call or after the call, you can certainly reach us based on the information on the screen here. Just a quick thing about Memex. In terms of our history, since 1992, we've been in business. But if you notice, the last 2008 onwards, you start seeing the advent of MT Connect, which is a protocol that we read natively into our software. It's gaining a lot of traction over a number of years here. And you can see some of our partnerships and some of the awards we've won over the last 10 plus years. So you can see that the OEE MT Connect mantras are becoming much more prevalent within our industry today. This is a brief, excuse me, a brief overview of some of our customers that we have. We have over 250 customers in our stall at the moment, but you can see, understand a wide variety of oil and gas, various industries and names here that I'm sure most of you are familiar with. And they're all customers that basically are trying to squeeze efficiency out of their shop floor and also helping them to manage the business better to make on-time deliveries. That's which is ultimately one of the goals here. We have partnerships, as I touched on a little bit, Microsoft a little bit, Mazak, Siemens. I just want to go over a couple of those real quick so you understand what our enterprise level looks like. From data-driven manufacturing standpoint, as I'm sure most of you all heard these terms of Industry 4.0, the IoT and IIoT, what this really means to the average person and what it really means in translation is all those convergence of those ideas ultimately get into what we're going to talk about today, which we call data-driven manufacturing. And that's really what this really means to somebody who has to get an IoT strategy in place at a particular facility. We're talking about 5 quick, easy steps that we use to set up our system, the connect, the visualization of the data, the analyzing the data, optimization, and then ultimately what the monetizing of that looks like. So this is a high-level view of a shop floor in terms of connectivity. So these 3 protocols that most of you, if you have manufacturing operations, could have MT Connect on a particular, it's OEM driven, a FNUC control with the focus library, or even OPC, which is PLC driven, are all native ways that we collect data from a machine and can ultimately be shown out in different dashboards that we'll show. We also are a hardware company. We have the capabilities of connecting any asset. I don't even use the word machine anymore in terms of data you want to collect. So if you have a heat treat oven, a plating line, it doesn't matter. We have the ways to connect that and ultimately push that data back into our system. As we all know, machines don't tell us everything. So we also have an HMI, a Merlin operator portal, for the operator to give us some information, which we'll talk about later. And of course, last but not least, the ability to connect the ERP system, in this case, Epicor, and ultimately measure full OEE. What we talk about here, we have a cloud-based option or we have a on-prem solution. So you have both options depending on how you want to structure the infrastructure for yourself. The key thing to understand is we sell the licensing as a perpetual license would actually be per machine, but the visualization of the data that we show actually is unlimited. So you could have all the people in your office and the shop floor, smartphones, all can consume the same data if that's how you want to see it. How we look at reporting and visualization of the data, you can see we break this down by several groups, by machine, by work cell, by shift, by product, by work order, and even by operator. So you have a variety of ways in our system to slice and dice through 36 canned reports that we have for you, or you have the ability to configure your own reports, which we train you how to do. And that's the way, so ultimately the idea here is to use the data the way that you want to see it. As we move forward in the course of time here, obviously any red conditions when the machine is down has been critical, but now we're getting into the slow condition. If my machine is running, why is it not running at 100%? And we're starting to measure that as a relationship to other factors that are going on the shop floor. The last, typically what we see is a 10 to 50% productivity increase. There's never one silver bullet here where this cost savings is driven. It's usually a lot of little things that kind of conspire together to actually give you the information and the cost savings you're looking for. And the basic equation here is a 2% profitability is seen from a 1% increase in OEE. That's why the ROI that you're going to see in a little while here is so dramatic, because it doesn't take very much to have a significant impact on the shop floor. And of course, that enables us, which we'll show later too, is how we get the IRR potentially at 300% or greater, depending on what the number of machines are and what you're looking to do. Okay.
Great.
Yeah,
good afternoon, everybody. Dave McPhail here. So what we're going to talk about now is impactful continuous improvement. I imagine most of you have some kind of continuous improvement program, whether it's Hoshin Kanri or Kaizen or 5 Whys. Impactful continuous improvement really is foundational. Real-time data is foundational impactful continuous improvement, is basically what I'm trying to say. And so we have the 5 steps here again, but we're slightly a little different. Yes, we have to be connected. We have to monitor and assess our manufacturing productivity in real time. We want to identify our bottlenecks and our constraints. We want to analyze for downtime and rejects and then eliminate them. And then we want to discover, ultimately, we want to do through impactful continuous improvement is discover our hidden factory and manage our operations proactively instead of just reactively. So we look at all the things that are improvement goals when we talk about impactful continuous improvement driven by real-time data. We obviously want to get to better root cause analysis. We want to improve our uptime and our quality. Frank's also mentioned about improving on-time delivery. We want to track OEE in real time, and we'll get into what overall equipment effectiveness actually stands for in a minute. And we want to measurably improve our profitability, and we'll get to that when we talk about our business case. When we look at what our reduction goals are, well, we obviously want to identify our bottlenecks faster. We want to reduce our unplanned downtime. If you're a high mix, low volume shop, you probably have a lot of setups going on, or think single minute exchange of die or SMED. We want to reduce our setup and changeover times. Our unproductive labor is a big one, or indirect labor. We want to reduce that. We want to eliminate manual data entry because for 2 reasons. First of all, it's latent, and second of all, it's usually inaccurate. And then if we do all of this, we're going to reduce muda, or what we call Japanese for waste is muda, but we want to reduce our costs and waste. If we look at a Kaizen event per se, what we're talking about here is there's 7 steps in the typical Kaizen event, and 3 of those steps are what we call non-value added. So they're collecting some manual data or running some reports from data that was input manually into a ERP system, as an example. We want to aggregate and analyze that data. Then we want to develop a countermeasure. We want to hypothesize a solution. We want to test that solution by collecting some more data to see whether it was accretive or neutral. And if it was, we're going to implement it and make it part of standard work. When we look at the factory that has real-time data available to fuel their impactful continuous improvement initiatives, really down to a 5-step event. We're not going out and manually aggregating data or analyzing it. We're simply running a report. Maybe we've been notified by email that certain things on the factory floor are offside. And so what we're doing is we're determining our root cause analysis by analyzing a report. We're then doing the same hypothesization of a solution, implementing a countermeasure. We're going to then let that run for, in some cases, a shift or two, or maybe a few hours on the same day. We're going to take another report and look at what the delta was between where we are now and where we were. And if it's accretive or neutral, chances are we'll implement the solution and make it part of standard work. And so what we've done is we've concatenated these non-value-added steps into these value-added steps by simply being able to fuel our continuous improvement initiatives with real-time data. And we've reduced this process down to 5 steps. And really what we've done is we've attained a culture of continuous Kaizen as opposed to doing, quote, Kaizen events, unquote. Next slide, please. Yeah. So here's a small video of sort of a root cause analysis in 12 clicks as an example of our system. I'll try to annotate it here, or color commentary. So essentially what we're doing here is we're going to run a utilization report for a particular area of the factory over a particular period of time. And so what we've done is we've seen that our utilization for this particular day has dipped. And so we want to then figure out, well, which part of that work cell of equipment was causing us the trouble. So we're going to run another little bit more detailed report. And we're going to see that the mill in this cell was the one that was dragging down the utilization number for that particular day. But we still want to know whether, what the root cause analysis of the problem is, or where do we need to focus our efforts. So we're going to run a Pareto downtime report. And we're going to see that we lost 13 hours here for maintenance, but we don't know whether that was a one-off breakdown or whether it was a systemic problem over a number of shifts. And so we're going to run one more report. And we're going to see that in this particular report, we've got the same 13 hours, but we've had 5 instances of it over a 24-hour period, and say a day and a half. And what we found out is that this is a problem that shows up every once in a while and then goes away. And if we can't see the trend, we can't fix it. And so that was essentially 12 clicks to get to root cause analysis, utilizing the reporting side of our tool. These are some of the things that we want to, as a benefit of continuous improvement or real-time impactful continuous improvement. We have daily team meetings with accurate data. We can reduce our setup time, our non-essential walking around time. We move from reactive to proactive when we have alerts and non-conformance reporting accuracy in real time, and then automatic reports on a daily, weekly, or monthly basis. And with that, I'll pass it back to Frank.
Thank you. So Dave and I have talked a little about OEE, overall equipment effectiveness, which really is ultimately the critical metric here. And it's made up of 3 KPIs, which is your availability or your utilization of the equipment as a percentage of scheduled time, quality, which is good parts versus a total part percentage versus bad parts, and then a performance, which also can be a standard rate, which is some rate that you say you're going to produce a particular part, and we're measuring you against that in real time to see how you're actually doing. This is the one metric that can actually be over 100%, which is good. That's what we want to see. And understand when we talk about OEE, that world class is 85%. That's the target we're going to shoot for, and we'll show you some math that goes around that later in the presentation. So as we talked about a minute ago, the key here is to reduce manual subjective data collection. We talked about real-time data collected directly from the machine, giving you real visibility in real time for actionable items, and basically to help you find the hidden factory. Where are those instances, as Dave just showed in the video, that talk about things that are happening that you may not know the cadence for, and you need to understand whether that's a chronic issue or not. This is a good example, and we put this in because we wanted to show you as an example here of where we want to go with all of you in terms of OEE. This is at 85%. This is what a world-class facility would look like. So you're going to have, and we'll talk a little further about the breakdown of these different buckets for down reasons is occurred here. But a typical, when we talk to folks, our typical reasons and percentages normally is about 40% in terms of OE. That's what they think they are. Normally they're at this 40%, but they may say to us, well, where do we think we're at 60%? But this scenario here is what we typically see in the marketplace. So that 40 or 39, 40% to 85%, this percentage in here is filled with all this downtime reasons that we're trying to help you find and uncover that hidden factor that we're talking about. So this is where we start. And again, we're going to get into an example that's much more detailed than this, but I want to give you an overview of what that looks like. And again, as I said earlier, there's no one magic bullet here for OEE or utilization of equipment. It's a lot of little things, and all the customers that you saw in our case histories earlier basically speak to a lot of little things that have ultimately added up into a nice savings for themselves. And these are just some of the areas that you'll typically see these percentages actually matriculate themselves. Okay.
Okay, so we're going to do is we're going to look at some situational awareness and what do these dashboards look like? What's possible from a visualization perspective? So if we this is one example. So this could be OEE real-time information directly from the factory floor for a group of machines or several machines or one machine. We see a trend chart. We have pie charts, exploded pie chart there. We have bar chart. We have radial gauges. Next slide, please. This is an example of machine utilization and throughput. You'll notice there we have real-time video in there, so that you could actually have IP cameras on the factory floor delivering real-time data directly, or real-time video feed directly to the dashboard. So rather than actually having to go out on the floor and see what's going on, we can see what the cadence looks like. This is an example of machine utilization and throughput dashboard. Again, these can all be created again with some additional real-time video feed from a manufacturing process. This is an example of what we call our event chart across the top, and so that's every state of the machine, and every state where it's gone green, it's actually in cycle. When it's not green, it's actually down for a particular reason. So we can actually show this as well. I mean, the dashboarding capability of the tool is virtually unlimited. I think you're only limited by your imagination. It's a website basically, all done with HTML5 and widgets in the background and all user configurable. Here's an example of a group of cells, a supervisor, essentially a supervision of a particular set of cells, some machines within those cells. Again, another shift throughput, an example. So again, I don't want to go into each and every one of these. There are so many different ways that the system can be configured to visualize your particular data set. It's a canvas. Here's another example of this. Has some third-party data on it, some tooling management data, some other things come from a different system, so you can actually aggregate the data from multiple disparate systems into one system. It's all driven by SQL Server, so there's Microsoft SQL Server on the back end. It's an open database. We don't encrypt it, so that you can have access to it with tools like Tableau or Business Objects or other intelligence tools to aggregate data as well, in addition to the way that we actually show it and report on it. Again, just another example. I think this might be the last one.
Yep. Okay. Thanks, Dave. So what we're looking to do here, again, as we deploy a project like this, at some point you start to look at the data, but down the road we start asking the questions. Well, how do we really drive continuous improvement from this data that we're now collecting, and how do we look at that? And that's where this Merlin performance management model starts to come into view. And also, we're going to show a few new data views that we have on dashboards to give you an idea what that looks like. So the first step of this is to actually bucket different down reasons, conditions that are going on in the machine. And as you can see here, between the in cycle, we also have down reasons categorized by machine type, by shop, job, maintenance, and reporting. And this is really critical to do this, because ultimately what you want to be able to do is direct the efforts of the projects to the people that are most affected by that, because some of the people that are affected by jobs would not necessarily involve the maintenance people, and vice versa. So you want to have the ability to start bucketing, and this is where the data we collect ultimately starts to form the pathway to get this actually done. So in the back end of Tempus, what you can see, here's these 5 groups that we just talked about. On the back end, when we look at different down reasons that we by default track, or you are looking to collect from a specific piece of equipment, we will then categorize these in this way. And this is critical to understand how we're going to bucket the information going into a continuous improvement mode. Here's a good example. So when we run a chart on one specific machine, we take these 5 buckets, as you can see, between machine, job, shop, maintenance, and system, which is actually the idle condition. And now you start to see the offenders here from each group. So now you can spend time, as example, our no material, which is a big offender here for the job. That may have something to do with scheduling or some other aspect that you want to focus your attention to, as opposed to looking at all these down reasons in one single bucket. You now have the ability to look, and that's what we've basically tabled out here, is by group, the occurrences and the amount of time that's accumulated against this chart. So you start to understand where you need to really direct your efforts. Again, this is just a little more of a running category here, as we talked about between in-cycle and the different various groups. But understand that this is also configurable, so that at some point down the road, an operator or someone in engineering may say there's a different down reason we want to track. We are able to insert that into Tempus and then ultimately report that back out. And that may change some of the dynamics here, but it's the flexibility of the system that Dave talked about earlier that enables you to be able to do that. We also have some throughput charts that we've also got into now. So this is by shift. You can see a day shift, afternoon, night shift, and you have thresholds. And what we're looking at then is in terms of the thresholds that have been set, and looking at a widget piece down here by shift to see if you're making the targets for production. It's just another way of looking at the data, but now we're getting into, as I said earlier, not just the down reasons, but now the slow condition, but also understanding the part counts and throughput, because people are asking us for more and more process data, process views to be able to manage their business better. So this is just another example of how we can do that. We also have, in support of this, is actually an electronic Gemba View. This is a solid screen, but what we can do is have a list of your machines down the left here, look at the utilization uptime by date, so you can be sorted here as a particular day, and then aggregated all the different down reasons that are here. But the important thing is, what we talked about creating the actual CI project, is this field below all the annotation that you see here is where you can actually click on this and create a project electronically. So you don't have to have a walk around Gemba board view that's a paper system. You now have the ability to show this on a dashboard or up on an add-on screen throughout the shop floor, and people can see what the projects are, what the current status is, when they're due to be complete. Again, all gets back to the same point, is real-time data collected directly from your machines. That's what drives all this to happen in its most purest form. And then here's a monthly utilization. Again, maybe a larger view for some folks, but again, you can see the different down reasons, so you can look at on a per day basis to see what's happening and aggregate this across the month in a much bigger view. So all part of the CI initiative that we start to get into in the Merlin performance management model, and this is part of what we offer, and this is part of the iteration of the next way to use our data as we start to move forward. And lastly, what you've kind of seen here, certainly we have competition like everyone else does. What we see with some of our competition is very simple machine monitoring, almost a stack light, in cycle, some kind of pause, or actually a stop condition. There's no ERP interface to Epicor. There's limited, if any, CI type constraint focus or any other insight as to root cause. It's very basic utilization. What we're looking to do instead, as we talked about, is give you a manufacturing operations management system where now you have an interaction with the operator directly. You have bisynchronous connectivity to Epicor, and then you have all 3 of the standards, KPIs, utilization, quality, performance for OEE. And basically now you have the cornerstone to start a true continuous improvement program, which at the end of the day is what we're really trying to do, as I said earlier, to squeeze the juice out of our system and maximize your return on what you paid for. Dave?
Okay, so now we're going to sort of talk about how we connect Epicor to Merlin Tempus. So Calvin and Fred have developed a product called the Coda Bridge, and essentially what that does is it takes the fields that are in Epicor that are relevant to Merlin and essentially transfer them to Merlin, takes the relevant fields that are in Merlin and transfer them to Epicor, and basically maps it seamlessly so that you essentially have exactly what the product's called. It's a bridge between Epicor ERP and Merlin, It's good for versions 9 and 10. We have several customers using it successfully. And so the question that we get asked a lot was, well, I really need to tie in our ERP system, but I have no idea where to start. This is a perfect example of a productized solution that can be purchased off the shelf, essentially, configured for your version of Epicor, and seamlessly transfer data from Epicor to Merlin and Merlin back to Epicor. When we look at the traditional input to ERP from the shop floor, you'll see it here. It's operator terminal data. It depends entirely on the operator action. It's reactive information. It generates lagging metrics in most cases. Certainly, at the end of a job, I spent this much time on a job. I had maybe this much downtime if they're even putting that in, and I made this many parts. That's just typically how ERP gets fed from the shop floor. What we like to think of as an automated machine-centric approach, where we have not just the data from the operator, but we also have data from the equipment. So we basically, what we talked about earlier was connecting the equipment directly to Merlin. And so now we have the data from, go ahead, one more, Frank. So now we have the data from the operator portal that goes into Merlin and goes directly into our database with the data in concert with the data from the machine. And the third piece that the Coder Bridge solves is now we have an open database connection between Epicor on the right and Merlin on the left. And so now we have the confluence of 3 data streams inside Epicor, but also inside Merlin, our manufacturing operations management system. And so there isn't necessarily a requirement to enter the data in 2 places. So that's essentially how we do it. Our operator portal is a piece of software that we've had out for a number of years, probably 8 at this point, and it's essentially replaces the kiosk on the floor in most cases, rather than having to key data in twice. You would essentially take your work orders and send them down to Merlin from Epicor, and then they would be selected by the operator based on whether if there's a run sheet, or run them in order, or whether you're running lean manufacturing where the operator decides what work order gets run. There's due dates so that everybody can see what the on-time delivery status of the work order is. There's a tremendous amount of information that comes from ERP that's available now to the operator in real time, and it gets mashed up with the data from the equipment so that it can be able to send back to ERP in real time to do things like drive inventory and procurement automatically.
Okay, so what we want to do now is we're to the point where we want to start building the business case. So I'm going to give you some of the overview, and then Dave will give you an actual example. So as we've talked earlier, as I mentioned earlier in the conversation, is we've always started in the past about the how. What does the technology do for you? How does it work? And how does that really ultimately get to where at least you want to go at that point? And we talked about the why last. Well, we kind of inverted the pyramid, and now we're going to talk about the why and how that really should be driving how you make these decisions, because the technology will certainly intuitively support the why, and that's what we're going to show here in a little bit. So a good example here is we're going to do some percentages, similar slides I showed earlier. So 85% over to the right, world-class. That means you have 15% that's known as acceptable down loss time, okay? If we look to the left, this again is a typical situation, 39% current running. What that means, we got the 15% that's acceptable loss, because the calculation for OEE is 95% times 95% times 95%. So that 5% gap in each of the KPIs makes up this intuitive 15%. But this is what's actually going on the shop floor. This is what we're trying to chew into. And again, as we talked about, we're now dividing this out between shop. We're looking at setup. We're looking at machine related, job related, maintenance related. This is all the different buckets that we want to ultimately chew into. So what we did then is we took that, instead of looking at, to simplify this down, we're now going to look at the same chart, but now we're going to look at it in terms of minutes. So that means at 85%, that's 51 minutes that you, in a world-class situation, that you'd actually be running with only 9 minutes acceptable loss. Or if you have the 39% that we talked on the last slide, that's 23.4 minutes that you're actually running, but you're accepting the 9-minute loss. But now in terms of minutes instead of percents, you now start to see what this looks like, because this is important to understand, because we talk in percents, that gets a little nebulous, but we start talking about actual minutes per hour per machine, it now starts to ring true because most of the calculations are based on that. So we wanted to show you a good representation of what this actually looks like. And again, this is the area in our CI initiatives, our Merlin performance model. That's what we're looking to actually impact, is this right in the air to ultimately drive you over to this part. Dave?
Yeah, so this is our business case builder tool. So this is what we use with our customers before we ever do an implementation, because again, as Frank said, we want to get the why understood, what the business outcome, expected business outcome is going to be, what are your unique challenges in your manufacturing operations that technology like this could overcome. So when we go to the next slide, please. So essentially what we're trying to do is upfront, and it's surprising how many customers know what their constraints are. They have an idea of what their constraints are. They just can't quantify it and exactly how much and exactly where. But for the most part, most people will know that they want to reduce their machine-related downtime, and there's a whole host of these reasons. There's probably 50 or 60 that we've come across in the 200 plus customers that we've got. Some of them are pretty standard, and some of them are somewhat unique. But for the most part, there's usually 4 or 5 reasons that most people can come up with of areas that they can target for continuous improvement. And so I've just listed some here. So go ahead and click, Frank. So here we've got our 5 targets and our minute targets, and we'll just review them. So reduce machine-related downtime. It's lost time due to machine not ready to run, so it has to warm up or whatever at the beginning of the day. Lost time due to setup-related issues. Some time saved due to increased visibility, and that's that whole proactive versus reactive idea. If we can see that the machines are all in green, they're running, that's great. But if we see some that are in red, we can react to it rather than collecting that time at the end of the shift and then saying, hey, we lost 3 hours on this shift for this particular reason. We can actually be way more proactive about it. And then reducing our breakdowns and our unscheduled maintenance. Maybe we do a little bit more PM or preventative maintenance. And so we look at the categories on the right. There's 2 machine related, 1 shop related, 1 job related, 1 maintenance related, as far as our performance management model is concerned. And so now when we look at the same sheet, we're going to go ahead, Frank, start clicking down. So we're going to estimate our current state of OEE. So in this particular example, we're going to say that this customer that we're working with is 55% efficient, which essentially means that they're accepting 33 minutes of total production and per machine per hour, and they're accepting a 27-minute per machine per hour loss currently. And then what we've done is, as on the previous slide, we've actually picked the 5 categories and the approximate minutes per machine per hour that we think we can turn from non-productive time to productive time. As we can see it, again, there's our area of MPMM, so performance management model, where we're going to concentrate. So essentially, the aggregate of these 5 continuous improvement projects aggregates out to 5.5 minutes, which reduces our acceptable loss to 21.5 minutes from 27, which is a 1.47 hours per machine per working day, or 29.33 hours across all machines, because in this example, we're talking about a 20 machine deployment. And our future state is increase in OEE is 9.2%. So it's a pretty conservative increase. We've gone to 64.2% in this example from 55. But our throughput is increased by 16.7% because we're picking up 9.2% on 55%, which is really 16.7% throughput increase. Next slide, please. And so when we look at this, what we've essentially done, click, is we've revealed these areas that we talked about for the 5.5 minutes. We're actually going to take them and we're going to convert them from non-productive time to productive time through our impactful CI initiatives. Click again. And what does that mean? That means that our production time has gone from 33 minutes to 38.5 minutes. So again, 5.5% or 5 minute increase. And so one more click. And then our acceptable loss has gone down. So you can see the green area in the future state on the right is 5.5 minutes better per machine per hour than the factory on the left, which is the current state. And so now you say to yourself, okay, I'm going to save 5.5 minutes per machine per hour for every work. What does that do from a financial perspective? So we have to put in the financial assumption. So we're going to put in our loaded labor cost in dollars. Click, please. So that's our fully burdened labor cost. We're going to put in the amount of hours that we work per day, the amount of days we work per week, the amount of weeks we work per year. So we get an idea of how many available hours that we have to work. And then we're going to say that for a deployment perspective, it's going to take us 1 month to integrate everything and get it up and running. So we're not going to count our IRR for the first month because it's going to take us a month to deploy, to go live. Cost per machine based on a 20 machine install is this. The total project cost is approximately $136,000. And then our number, in this particular case, we're going to generate a 4-month payback or 300% internal return rate. And so then again, what does this look like from a financial perspective? Next slide, please. Our total dollars saved over 1 year is $668,000, and over 3 years is $2 million. These aren't made up numbers. We've got lots of examples and case studies of customers that have numbers good or better than this. Go ahead. And so this is maybe a little bit difficult to read because it's small, but essentially what we're saying here, for every hour that this machine is operational, if we can claw back those 5.5 minutes, this is what it means per hour, per day, per asset per day. So go ahead and click, Frank. So we're talking about this many dollars per hour, this many dollars per day, about $760 per asset per month, so many dollars per year, and then all assets over the year is $182,000. And then you add up all the other numbers that are in the other 4 identified projects, we get to a pretty healthy number of about $670,000 return, or approximately a 4-month payback. So go ahead and just click through this slide, Frank. Right?
Yeah, okay. We're good.
Yeah, just keep clicking. There's animation on it.
There you go. Can you see that okay?
Apparently I just got logged out of the meeting somehow. Go ahead and pick up, Frank, and I'll log back in.
Okay, so this is actually our last slide, but this is just the overall summary report. So as we talked about, so you have a cost, you have a net gross dollar saved per year of 668,000. Then the net of that is actually the gross minus the cost of the project and also the annual maintenance. And then year 2 and year 3 that you see in gold is basically the difference between the gross and the actual here in yellow minus the annual maintenance, which is due every single year. So that's how you start to see, and again, recapping this, a throughput increase of 16.67%. The future state is 9.2%, an OEE increase. Unproductive hours, all day assets is 29.33. Unproductive hours converted is now 1.47. And again, as Dave said, you have a 4-month ROI with a IRR of 300%. So the numbers can be pretty eye-popping, certainly, but I think the key is, I will go back here just a second.
But Frank, I'm sorry, I was just looking at your math there, Frank, and that has the cost savings, but it doesn't have the increased throughput of the machine. The revenue, the additional revenue that you generated as well by having those extra hours on the machine captured.
And Calvin, you're 100% correct. And essentially the return on investment from a profitability perspective, it can be a 10% increase in OEE is a 20% increase in profitability if you sell the same volume. It can be up to a 60% increase in profitability if you sell everything you can make. So that increased capacity, if you can sell that increased capacity, the only thing you're paying for additionally is material. The labor's covered, all the overhead's covered, everything's covered but material. So you're absolutely correct that the savings here are strictly straight line on reduction of labor and increase in throughput. It does not account for the additional profitability of the additional throughput. That's kind of a bonus gift.
Okay, we've got a question also online from Scott Williamson.
Sure.
Regarding Merlin MES integration, sounds like a solution for machines to produce parts, but in a lot of our manufacturing, the operators produce large equipment. How would the software work with an environment where the machinery is produced by people, not the machines?
So we virtualized the concept of a machine. So essentially, the operator portal, that the actual manual process or assembly station or any value-added activity shows up as a machine in the dashboard, just like any other machine. The operators we'd be a little bit more dependent on the operator to tell us what's going on, but it works exactly the same. The operator would say, I'm producing, I'm in cycle right now, I'm producing a part, or I'm working. How many parts did I make? They put that number in. If there's material required or any other constraint issue like material conveyance or dunnage or anything, they can fire an email out from the terminal directly to whoever's responsible. All those tools apply. The only difference is the data stream becomes the data coming from the human capital on the floor and not necessarily an automated machine. But it's from a dashboard perspective and a reporting perspective, it looks exactly the same.
Okay,
we have several customers that have blended those two types of resources together. Manual value-added activities versus automatic machine-related production.
Okay, and then we had another question in from Faye. Is it possible to read data from machine and sync to issue material and time and expense for real-time data entry in order to avoid manual entries? There are PCB and PCBA industry, almost everything is done by the machines. And Fayez, that's what the Coda Bridge actually does, is it pulls the machine record data and converts it back into a labor record and puts it into Epicor in real time. Did that answer the questions?
Okay, quick summary here for everybody. We talked about data-driven manufacturing, and this exists in the marketplace today. Everything we're talking about is currently deployed, so there's really no reason to wait. The 300% IRR we talked about is pretty standard in our business and what we try to accomplish for our customers. This is a known pathway. The pathway from Tempus as Caleb just said, into Epicor is pretty well known and established. So we've talked at length here about what the why is and why we should discuss that first. We have a cost-effective solution, and we solve, since we're a Canadian company, we solve the last meter problem. We connect directly to the machine for data collected in real time. That's important. We're not collecting data from a third-party PLC or PC necessarily, and they have the ability to connect to any and all assets. So there's a whole laundry list of both manufacturing and fabrication and even assembly plant type applications, as you guys alluded to a minute ago, that we can connect to even using the Merlin operator portal. And obviously there's a direct link, as you can see, between increased productivity, and last but not least, certainly want to have discussions regarding security of these systems. That's a key thing in most people's minds these days, and we have some things we could talk about offline relative to that to make sure that this is actually deployed in a proper manner. Understand that as Memex, we've deployed to a number of Department of Defense and aerospace customers who have pretty strict guidelines for running a system like ours. So we certainly are familiar with formatting and infrastructuring our product to meet those requirements. Does anybody else have any other questions?
I think there was one question about could they see the Merlin operator portal? You want to? I mean, we didn't put, in the interest of time, we didn't put really product-specific slides other than some of the situational awareness slides. But we've got a few extra minutes here, Frank, 5 minutes, I believe. So I think we can pull up a slide or two that shows the operator portal.
I think so. If I can see if I can minimize this. And here, hang on a second. Let me see. I think I can do that. I'm not sure why that's.
Or just take it out of slideshow mode.
That's what I'm trying to do. Is just get it.
Just the escape key.
Yeah, that's what I'm doing, but it's not letting me do that.
Control D. Frank, Control D.
Yeah. Okay. Yep. I did that. It's not working.
Well, windy now.
Yeah, I don't know. It's the system locked up or something. It's not doing anything at the moment.
Well, we could certainly, with Scott, we could certainly set up another discussion outside of this meeting where we could go through the operator portal and anything else that, from a technology perspective, that you want to see. If we can't get it done here in the couple of minutes that we've got left.
Yeah. So
Hey,
Calvin,
Frank.
if you have his contact information, I'll be happy to email him some stuff and we can get on a quick session. I can show him that. It's not a problem.
Yep.
Hey, Frank, go to the bottom left of your screen. It seemed like when you hovered there, there were some extra dots on your screen
Your other
on the
left.
left-hand side. Nope, it's locked up on you. Okay.
Yep. I don't know what happened, but it did.
F11.
F11. Okay. Let's see.
I'm just reading what's going on the screen.
Okay.
There you go. The ellipsis. End show.
There we go. Okay. Now maybe I can do this here real quick. Hang on just a second. Let me see. Bear with me just a second here. Here we go. So what I can pull up real quick here is this is actually a view of the operator portal for everyone who can see that. But I think more importantly, let's go through, and this is the functionality down the side here, a completely configurable device, so you can show as few function or as many as you want. So if we look at the full menu here, which is this slide, if everybody can see it, what you have the ability to do then is log in and log out an operator. And again, this application is Windows based, so it'd be located near the asset that we're tracking, and it also can track more than one-to-one. It doesn't have to be a one-to-one ratio. You can have 3 or 4 machines or assets tracked to one instance of the mop. You have the ability then to see the work orders, change work orders, select work orders. You also have the ability to change machine states. So if we're in the setup mode, as an example, we can go back in a modal condition and get back into in-cycle condition. You have the ability to make comments on the machine state. Let's say that somebody fails to log out from a setup mode. We can go back in and log in and say, well, I was 2 hours over because I forgot to log out. So you'll be able to backflush some data in a history editor. You have good parts and bad part counts if the machine doesn't give us that information. Also understand that on a reject basis, we can configure reasons why a part's rejected by a machine. It's out of roundness, it's out of tolerance, it's rusty, it's oily, whatever reasons you want. You also have the ability, and the operator would have the ability then to send designated emails to specific departments or circumstances you wanted to contact. I'm one of your operators, and we have to do a first off article on a brand new job. At 30-minute cycle, at 15 minutes, I can walk over to the operator portal, hit send email, connect me to the quality first off, and ask them to come out to my machine to sign off on a quality first article. Instead of me going to find somebody, leaving the machine alone, 15 more minutes passes by and the machine goes into idle because the machine's ready to run and it's not running. That's the type of stuff that we're trying to circumvent with the system to give you more visibility. You have the ability to both scan and create barcodes on the operator portal, and there's also a work instructions. So let's say that you have a situation where maybe you have a complicated setup and you want to shoot a YouTube video and place that on it because experienced operator can save that video on how to do a complicated setup so that future technicians can come in and learn from that. So that's a quick overview, but that's the functionality of the operator portal. It's an integral part of what we do. The operators, as we all know on this call, have a lot to say for what's going on the shop floor. We want to give them a tool that makes them the center of the universe and brings all the resources to them. So happy to
we call that whole concept support the internal customer. We treat the operator as the internal customer, and we can bring them everything that they require, that they require to be successful. Productivity goes up.
Does anybody else have any other questions? Well, Calvin, we're right on time.
Perfect. So far, so good.
Okay. I guess we're all set up.
We'll give people a few minutes if they do have questions and they're not on audio, they can go ahead and type it in here.
Okay.
Scott, did that cover sort of off a brief overview of the operator portal?
Yes.
Thank you.
We got an answer. Yay.
Okay. So there's a copy of the presentation in PDF form already up. I sent that to Fred actually earlier today. Unfortunately, in the PDF form, those videos that we showed will not be visible, but everything else should be. And Dave and I are available for questions if you certainly like to do that. And again, if you need to reach out, certainly you folks here in the Midwest. I mean, I cover the greater Midwest for the company, so I'm your contact person. Feel free to reach out to us, and we'll certainly help you any way we can.
And we have a couple people have said they're looking to reach out. David and Fayez, what I'll do is we'll send out the meeting notes and we'll put direct contact for all the presenters. So if you have a question for Jose, have a question for Frank, have a question for any of them, you'll have contact info so we can kind of put people together and get connected here.
Great. Thanks, Calvin.
Yep. Dave, did you want to mention about next week while we're on the call here with these guys?
So we have a webinar going on next Wednesday that'll be a little bit, I think most of it will be similar to this in terms of the business case, but it is next Wednesday at 2 p.m. Eastern time. If there's any interest in that, Frank, if you could just pull up our email slide, just go back to the previous presentation and just throw up the business card slide. I think the third slide in on the presentation that should have all contact information on it. People can just snap a picture of it in the interim.
Yep. There we are.
So just go to slideshow, go to presentation mode because it's too small to read.
Okay.
Slideshow from the current slide.
Okay. There we are.
There you go. So yeah, that you need to get a hold of us. There you go. And we're certainly happy to go deeper dive with a demo of the product if anybody's interested. And I'm sure Calvin will participate if there's questions about the Coda Bridge. Been very good about doing demos to our customer base as well.
And what I'm doing right now, I'm sending a copy of your webinar coming up on the 27th. So when we send out the notes here in a day or two regarding the meeting, we'll have a copy of that invite if anybody wants to join in on their demo on the 27th. I'll include a copy of the email in there for you guys. Since I know you can't wait more than 7 days, you got to register. And
Yep. Thank you, Calvin.
okay, Rob, go ahead.
No, I think we're good, Calvin. I think unless anyone else has any other questions, I think we're in good shape.
Scott Williams is asking, does the software show routings?
Yeah, as long as they're op steps, a family of op steps. So as long as your op steps are, op 10, op 20, op 30, and it's all part of the family of parts, then the answer is yes. We have
next operation would be there as well.
Yeah, exactly. And you can also show what happened on the previous operations and what the next operation is going to be. We have a whole view of what the production schedule looks like in a family of parts. So there's a whole hierarchy from the part number and exploded down to all the different components that make up that part number or make up that finished part. And most of that information comes from Epicor. In fact, all that information comes from Epicor. Think of it like a bill of material.
It's going to communicate it using the RESTful API calls between the two systems, Scott. So the Coda Bridge looks at it and, as the person clicks like job release, we tag on to that method, and then we send the data. If there are related resources that are part of the Memex system, then we push those operations and routings direct into the Memex system. If you have a job that doesn't utilize a Memex resource, like a maintenance job or something, possibly where it's not on a machine that as part of the Memex, it doesn't send that over to the system. We're not throwing all the data. We're only throwing that which is pertinent over to it. But we integrate it directly with the method so that when you click release the job, we push the data directly over. If you update an employee or a resource, when you click save, we automatically push the data over if it's tied to Memex.
Our entire solution stack's built on, I think we're up to about 600 RESTful APIs at this point. The whole operator portal, how it communicates with the host application, the core application, is all done through RESTful API.
Any other questions for Dave or Frank here?
Thank you very much, everyone. We appreciate your time.
Yeah,
Awesome,
thank you.
guys.
Thanks very much.
Let me go ahead and make sure before you guys take off, it was the email sent from gord@memexoee.com.
Correct.
Developing the business. Okay, I wanted to make sure I sent the right email over to Fred.
Gord's our virtual marketing guy.
Got it.